There are a couple of things from the videos that are included in the ebook on my math lab that I thought weren't covered quite as well as I'd like to see them covered. So this recording is going to be a few extra examples just to help you out just a little bit more. First of all, if we have an example like you see on your screen, 6x to the fourth minus 18x cubed plus 12x squared, and the directions are to factor, we would start by looking for the greatest common factor. And I kind of think about it this way. I look at each of those terms, and I'm going to think about the numbers first, 6, 18, and 12. And I think about what is the biggest number that will divide into 6, 18, and 12. And the answer to that question is 6. So 6 is going to be part of our greatest common factor. And then we also have powers of x in each of the terms. You look for the smallest power of x, and that's an x squared. So 6x squared would be our greatest common factor. Now, the way I think about finishing this problem is I'm going to take each term, and I'm going to start by looking at 6x to the fourth power. And I'm going to think about dividing 6x to the fourth power by 6x squared. 6 divides into 6 once. X squared divides into x to the fourth. X squared times. And then I look at the next term and I kind of go through the same things. The negative, remember, goes with the 18. So I'm thinking 6 divided into negative 18 is negative 3. And then x cubed divided by x squared is x. And then finally, positive 12x squared. 6 divides into 12 2 times. X squared divides into x squared 1 time. So when I'm thinking about factoring, I'm thinking about dividing, because that's essentially what you're doing. Now to finish this, we look at this trinomial and see if we can factor it. Bring down the 6x squared. We'd look at x and x as the first terms in the binomial. If we use 2 and 1, those will multiply together to give us positive 2. But if we use negative 2 and negative 1, that'll work also. And negative 2x and negative 1x would give you the negative 3x term you need in the middle. So there's my final answer factored completely. Okay, we also want to talk about the sum and difference of cubes, which was just mentioned in passing in the video for section P5. You were told to just refer to the chart that was in the book, and that's fine. But I think the sum and difference of cubes formulas are a little hard to remember unless you think about it a certain way. So let's just start with this. A cubed plus b cubed will factor. It's going to be two factors. The first one is going to be a binomial, a plus b. So whatever the cube root of the first term is and whatever the cube root of the second term is. And then the second factor is a trinomial. It's a squared minus the product of a and b plus b squared. Now the formula to factor a difference of two cubes follows the same pattern. The signs are just different. So really, if you can memorize the pattern a and b, a squared, product of a and b squared, and then you think about the word SOAP. SOAP will help you get the signs right. S stands for the same. So your first sign is the same as what you started with. We had an a cubed plus b cubed, so we start with a plus. The second sign is the opposite. So since we started with a plus, now we have a minus. The A and P go together for always positive. The last term is always positive. So thinking about it that way, the formula for the difference of two cubes would be A and B with a negative, and then we'd have A squared plus A times B and another plus B squared. So let's look at an example. That's not the example I want. We need to factor 64x cubed plus 27. Okay, now here's the way I'm going to think about this. 64 is 4 cubed. So that 64x cubed is like 4x all raised to the third power. 27 is 3 cubed, so it might be helpful to start by writing it that way. And then use your formula. We'll have 4x, the same sign, and 3. Then we'll have 4x, quantity squared, the opposite sign, the product of 4x and 3, a positive sign, and 3 squared. And then it's just a matter of cleaning that up. 4x plus 3 times 16x squared minus 12x plus 9. And then of course you can always multiply that back together to check your factoring. One last thing. In working with rational expressions, an example was worked for you on the video where you were multiplying rational expressions, and then the professor just talked about what to do to divide. I want to actually work through a division problem for you. When dividing fractions, you invert the second fraction and multiply. So your first step in a problem like this is to change this to a multiplication problem. And the x squared plus 5x plus 6 moves up to the top. And the x squared minus 1 comes down to the denominator. Now you want to factor each of the parts of the two fractions. So we can factor out a common factor out of x squared plus x. X squared minus 4 is a difference of squares, so we'll have x plus 2 and x minus 2. And working on the next fraction, we'll have x and x, 2 and 3 will work, and if they are both positive, they'll give you the right middle term. And then we've got a difference of squares again, x plus 1 times x minus 1. Now we can reduce. We want to cancel as much as we can. We have an x plus 1 in the numerator of the first fraction and an x plus 1 in the denominator of the second, so those will cancel. We have an x plus 2 in the denominator for the first fraction and the numerator for the second fraction, so the x plus 2's will cancel. So then multiplying what's left, x times x plus 3 in the numerator and x minus 2 times x minus 1 in the denominator. And then to exclude positive 2 and positive 1 is going to give you all the information you need in that final answer, because 2 and 1 are the two values of x that would make that denominator 0.